Good day everybody. We have a beautiful question which was asked at MIT 2023 Integration B Finals. We expected to integrate integral -1/2 to 1/2 root of x squared positive 1 positive square root of x to the power of 4 positive x squared positive 1 times dx. Now we got a sort of nested square root. So to solve this, what I wish to do is let us consider square root of x squared positive 1 positive square root of x to the power of 4 positive x squared positive 1 to be equal to, say, some root of a positive root of b. Now what I wish to do is I would like to be squaring both sides. So when I do that, this is going to be raised to the power of 2, this is going to be raised to the power of 2. Naturally, the first square root gets neutralized by this 2 here. So we would get x squared positive 1 positive root of x to the power of 4 positive x squared positive 1. You expand this, this would give you a positive b positive 2 times root of a times root of b. I'm using a positive b raised to the power of 2 expansion. Now what I wish to do, I would like to equate quantities without square root and quantities with square root. So this is going to give me x squared positive 1 to be equal to a positive b on one side and square root of x to the power of 4 positive x squared positive 1 to be equal to root 2 times root of a times root of b on the side. So this is what we have got. Now squaring both sides again on this end, we get, what do we get? This is going to be raised to the power of 2, this is raised to the power of 2, this is going to give me x, let me just retain it as it is, x squared, or let me expand this, okay. So if I were to expand this, this is going to be x to the power of 4 positive 2 times x squared positive 1, this is equal to a squared positive b squared positive 2 times ab. Now squaring both sides over here, we get, so this is raised to the power of 2, this is raised to the power of 2, so the square root and the square, they get neutralized, giving me x to the power of 4 positive x squared positive 1 is equal to 4 times a times b. Now what I wish to do is I would like to name this, say, sum 2 and name this as 3. So 2 minus 3, I'm going to perform that operation. So if I were to perform that operation, let me take this and place it over here, x to the power of 4 positive x squared positive 1 is equal to, let me take this and place it over here. Now I'm going to subtract. So this is going to give me x to the power of 4, x to the power of 4 gets cancelled, 2x squared with negative x squared, when you add them, this is going to produce x squared, positive 1 negative 1 gets cancelled. Over here a squared would be brought down, b squared would also be brought down, positive 2ab negative 4ab, when you subtract you get negative 2ab. Now this is a negative b raised to the power of 2, on the left you got x squared. So therefore you can rewrite this as a negative b raised to the power of 2 is equal to x squared. So from here you get a negative b is equal to x. So this is one equation you have got. Now prior to this, before the squaring, if you would have observed, when we equated, we add what is x squared positive 1 is equal to a positive b, right? And from here we started squaring both sides, and that's why we got this. So if I were to consider this say sum 1 prime and consider this as some 2 prime. What I'm going to do is I'm going to be, let me write that statement, consider 1 prime and 2 prime. So this is going to be a positive b is equal to x squared positive 1, my 1 prime. My 2 prime is a negative b is equal to x. Now solving and getting the value for a and b, that is the objective. Okay, we need to solve this and get the value for a and b. Now to begin with, we can eliminate b and we get 2a is equal to, this is x squared positive x positive 1, therefore a is equal to 1 over 2 times x squared positive x positive 1. So this is the value for a. Now let us eliminate a now. We have eliminated b. Let us eliminate a now. So let me write that down. You get a positive b is equal to x squared positive 1, and then a negative b is equal to x. So if I were to eliminate a, I take a negative sign here, right? So this is negative, this will become positive, this is positive, this will become negative. So a gets cancelled, you get 2 times b is equal to x squared negative x positive 1, therefore b is equal to 1 over 2 times x squared negative x positive 1. So this is the value for b. Now if you would were to consider the first step, we started off like this, right? So in fact I am having squares on both sides for the very fact that I used this sentence, okay, squaring both sides, and hence I have squared them. Actually we started off with this particular statement, that is, consider square root of x squared positive 1 positive root of x to the power of 4 positive x squared positive 1 to be equal to root of a positive root of b. This is what we took in, and then we squared it, right? And that's the reason I just placed a parenthesis and raised them both to the power of 2. So the concept what I'm trying to show you here is, in place of this I'm going to replace root of a positive root of b. So the original question, let me take this as 1, can now be rewritten as, therefore 1 can be rewritten as integral negative 1 over 2 to 1 over 2 root of a positive root of b times dx. But what is my root of a? This is negative 1 over 2 to 1 over 2. My a is this value, right? Substitute that. So this is going to be square root of this entire thing, 1 over 2 times x squared positive x positive 1 positive 1 over 2 times square root of my b is x squared negative x positive 1 times dx. Now I can take this 1 over 2 out, right? So that's going to be 1 over root 2 because it's within the square root. And integrating from negative 1 over 2 to 1 over 2, you get square root of x squared positive x positive 1 times dx positive integral negative 1 over 2 to 1 over 2 square root of x squared negative x positive 1, right? So this is what you have actually got. Now let me just take the first part and solve it, or I would say integrate it, and then second part integrate it and add them both, and then simplify and get the answer. So that's the objective, that's the way we would be proceeding. So let me consider x squared positive x positive 1. Now the question is, how do I write, I want to write x squared positive x positive 1 as a perfect square. So is it okay if I write x positive 1 over 2 raised to the power of 2? I expand this, I get x squared positive 2 times x times 1 over 2. So the 2 and the 2 gets cancelled, giving me x. But there is a 1 over 4 there, right? But I need to get 1 year. So 1 over 4 added with 3 over 4 will give me 1. So this is the perfect square part. Now let me just consider over here x squared negative x positive 1. Is it okay I write x squared negative x positive 1 over 2 as x negative 1 over 2 raised to the power of 2? What happens when you expand this? I get x squared negative x and positive 1 over 4, and I need to get a 1 here, so I need to add 3 over 4. So this is the perfect square expansion. Now this can be further rewritten as x positive 1 over 2 raised to the power of 2 positive root of 3 over 2 raised to the power of 2, and similarly this can be rewritten as x negative 1 over 2 raised to the power of 2 positive root of 3 over 2 the entire quantity is raised to the power of 2. So what I wish to do is I would like to consider this first, then in place of x squared positive x positive 1 I would be using this, and then I will integrate, and then onwards I will come to this part, I will integrate, and then I will fuse them both and I will simplify and get the answer. So that's exactly what we are going to do. So let me move on to the next page. Okay, so as mentioned, I have just taken the first integral. We have got root of x positive 1 over 2 raised to the power of 2 positive root of 3 divided by 2 raised to the power of 2. So now I would be taking the assistance of hyperbolic substitution. So let me take x positive 1 over 2 to be equal to hyperbolic sine, which is shin, right? I'm going to take it as shin u. Now since I have a root 3 over 2, I need to place root 3 over 2 there. If I differentiate, I get dx is equal to root of 3 over 2. Differential of shin is going to give me cos u times du. That's it. So substitute it here. This is equal to, now I need to set the limits, but I'm not going to do the setting now as of now. Let me just place in the values. So this is going to be root of x positive 1 over 2 is this. So I square this. When I square this, I get root of 3. So let me just have it as root of 3 over 2 squared times shin squared u positive root of 3 over 2 raised to the power of 2. In place of dx, it is root of 3 over 2 times cos u du. Now root of 3 over 2 can be taken out. In fact is a square. This is can be out, root of 3 over 2 square, and this is going to give me shin square u positive 1. The entire thing is under root times this root of 3 over 2. I can take this out like this, and this is going to be cos u du. Now if it comes out, this is going to be root of 3 over 2. The 2 and the radical sign will get neutralized, the square would get neutralized, so this is going to be root of 3 over 2. Now there is a formula, make use of this particular formula, which is negative shin squared u positive cos squared u is equal to 1. This formula is also represented as cos squared u negative shin squared u is equal to 1. This formula is also represented as cos squared u is equal to 1 positive shin squared u. And this formula is also represented as cos squared u negative 1 is equal to shin squared u. So there are several ways that this particular formula is represented. What we will do is we will make use of this particular deduction, cos squared u is equal to 1 positive shin squared u. So if I were to do that, this is going to be root of, in place of shin squared u positive 1, I would be utilizing cos squared u. So this is cos squared u. There is also a cos u there. So cos u du. Square root of cos squared u will be cos u. So cos u times cos u will give me cos squared u times du. Root 3 into root 3 will give me 3. 2 into 2, that's going to give me 4. Now the question comes, we need to set up the limits. That's very important because this is fine. Now going back to the substitution, x positive 1 over 2 is equal to root 3 over 2. Now let me just show you the limits. This is negative 1 over 2, x takes, and positive 1 over 2. These are the two values x takes. Now the substitution is x positive 1 over 2 is equal to root of 3 over 2 shin u. Now for the lower limit is negative 1 over 2. So when x is equal to negative 1 over 2, this entire thing becomes 0. Right? This means u is equal to 0. We got to find it for u. Now next step, when x is equal to 1 over 2, I substitute 1 over 2 here. So 1 over 2 plus 1 over 2 is equal to root of 3 over 2 times shin u. This is going to give me 1, right? 1 over 2 added with 1 over 2 is going to give me 1. And 1 is equal to root of 3 over 2 times shin u. You cross multiply, you get 2 is equal to root of 3 shin u. And then you bring this root 3 down, so it's going to be 2 over root 3 is equal to shin u, but you need u, so move this shin to the other side. So u is equal to shin inverse of 2 over root 3. Right? So this is what you have for u. So the limits are 0 to shin inverse of 2 over root 3. That's it. I'm not going to do the integration as of now. Let me also get the other quantity. So we will consider the other integral. Now consider the second part, which is negative 1 over 2 to 1 over 2 square root of x negative 1 over 2 raised to the power of 2 positive 3 over 4. In fact, I want to write it as root of 3 divided by 2 raised to the power of 2 times dx. Okay. Now I can use the same hyperbolic substitution. Let x negative 1 over 2 be equal to root of 3 over 2 shin u. Dx is equal to root of 3 over 2. Differential of shin u will give me cos u du. So in place of x negative 1 over 2, I'm going to substitute this. Is going to be root of 3 over 2 square times shin squared u positive root of 3 over 2 squared. In place of dx is going to be root of 3 over 2 times cos u times du. I can take root of 3 over 2 out. I can also take root of 3 over 2 out. And I have an integration of shin squared u positive 1 times cos u times du. We will use the formula shin squared u positive 1 to be as cos squared u. Root of 3 into root of 3 is 3. 2 times 2 is 4. This is root of cos squared u times cos u times du. This is equal to 3 over 4. Square root of cos squared u is cos u times du. You multiply both together. This is going to give me 3 over 4 integral cos squared u times du. Now the limits. Now I substitute the upper limit. The upper limit will give me 0, right? But I substitute the lower limit. So you can write it. When x is equal to 1 over 2, u is equal to 0. But when x is equal to negative 1 over 2, what do I get? Negative 1 over 2 added with negative 1 over 2, I get negative 1 is equal to root of 3 over 2 times shin u. Cross multiply, you get negative 2 over root 3 is equal to shin u. Now we need to get u. I don't have space, so I'll show that over here. So you got negative 2 over root 3 is equal to shin u. You need u, therefore u is equal to shin inverse of negative 2 over root 3. Now you can take the negative sign out and write this as negative, right? It's always possible to do that. Negative shin inverse of 2 over root 3. So this is what you got, right? So this is one of the limits. So I can rewrite this as integral. This is actually the lower limit. Upper limit is 0. The lower limit is negative shin inverse of 2 over root 3 times cos squared u times du. Now this is the second part. So I need to take this part. Okay, of course there is a 3 over 4. I need to place the 3 over 4. I need to take this part and this part add them together, then perform the integration. So since I've exhausted this space, let me go to the new page. This is what I've got. Now you might be wondering, how did I arrive at this? Now we know the first one gave us 3 over 4, integral 0 to sin inverse of 2 over root 3 times cos squared u du. The second one gave us 3 over 4 integral negative sin inverse of 2 over root 3 times cos squared u du, right? So I just clubbed these two and I got this. Now what I wish to do is I would like to multiply this by 2 and divide this by 2. So this is going to give me 3 over 8 integral negative sin inverse of 2 over root 3, and this is going to be sin inverse of 2 over root 3 with the positive sign. Now we have a formula. What is it? 1 positive cos 2u divided by 2 is equal to cos squared u. I cross multiply this 2, so I get 1 positive cos 2u is equal to 2 times cos squared u. So in place of 2 times cos squared u, I'm going to substitute 1 positive cos 2u. So this is going to be 1 positive cos 2u times du. Now I can rewrite this 3 over 8. Now you have to have in mind that this entire integral has 1 over 2 outside. I am not taking that 1 over 2, right? 1 over root 2. You got to let me, if you were to observe this integral, let me show that to you over here. You see that this has got 1 over root 2. So I am not taking that 1 over root 2 as yet. I'm just dealing with this and this together. So just to give a reminder. So this is nothing but 3 over 8 and integral the limits du. This is going to be negative sin inverse of 2 over root 3 and positive sin inverse of 2 over root 3 times the du. Du is already there. I don't need to place du. So let me just make it a parenthesis. Positive integral negative sin inverse of 2 over root 3 positive sin inverse of 2 over root 3 times cos 2u times du, right? Now if you were to integrate this is going to give you 3 over 8. Integral of du is going to give you u. The limits are negative sin inverse of 2 over root 3 and the upper one is going to be sin inverse of 2 over root 3 with a positive sign, followed by, if you have to integrate cos 2u, this is going to give you sin 2u divided by 2. The limits are negative sin inverse of 2 over root 3 and positive sin inverse of 2 over root 3, right? This is what you've got. Okay, that looks fine. Now the question comes, you will have to make the substitution. That's very critical, right? So let me just substitute the upper limit here. Now before we could also substitute, I know you are going to be wondering, how are we going to handle this sin inverse of 2 over root 3? Now there is an easy way. Okay, before I could do that, let me just substitute the limits. So 3 over 8, I substitute the upper limit, sin inverse of 2 over root 3, upper limit minus the lower limit, which is negative sin inverse of 2 over root 3, right? Upper limit minus the lower limit. This is one part, followed by, I was just thinking of placing a parenthesis, but it doesn't matter. If you want, you can place a parenthesis like this. So just to show this part belongs to this. Positive Now shin 2u, what is shin 2u? Shin 2u is nothing but, it's similar to sine 2 theta. Sine 2 theta is nothing but 2 sine theta cos theta, right? So we can use the formula. This is 2 times shin u times cos u divided by 2. 2 gets cancelled. Now we can place the limits. The limits are negative shin inverse of 2 over root 3 to positive shin inverse of 2 over root 3. So this is how we are, how to place or how to put it. So this is the outcome that we have got, right? So now we need to substitute the upper limit minus lower limit for this part. Now let me simplify this part. So this is equal to 3 over 8. Now shin inverse of 2 over root 3 followed by a negative of negative, that's going to be positive. So you got 2 shin inverse of 2 over root 3, right? And that's going to be 2 times of shin inverse of 2 over root 3. This is the value that you've got. Followed by, let me just place the upper limit here. So shin u, in place of u, you have to place shin inverse of 2 over 3. So that's going to be shin inverse of 2 over root 3, right? Times cos u. Now how do I handle cos u? That's an important question, right? Now let me just show you this. Now I started by giving you this formula. What is the formula? Cos squared u is equal to 1 positive shin squared u. In place of 1 positive shin squared u, this is the formula we substituted. Now if you were to throw this 2 on this other side, it will become square root of this. So this is going to be square root of 1 positive shin squared u. So this is my cos u. Now I need to substitute the upper limit for root of 1 positive shin squared u. So if I were to substitute, I'm going to substitute in this fashion. So this is nothing but root of 1 positive shin squared u is nothing but shin u times shin u. So now I substitute the limit, the upper limit over here. So that's nothing but root of 1 positive shin, in place of u I got shin inverse of 2 over root 3 times shin, in place of u it's going to be shin inverse of 2 over root 3. This is what we have got, right? So shin and shin inverse gets cancelled, giving me 2 over root 3. So this is going to be 1 positive 2 over root 3, and shin inverse and shin gets cancelled, giving me 2 over root 3, which is equal to root of 1 positive 2 2s are 4, root 3 into root 3 is 3. You take the LCM, this is going to be root of 7 over 3. This is what I've got, root of 7 over 3. And I can take this value and place it over here, because this is cos u. Cos u is root of 7 over 3. So just place that root of 7 over 3. So this is for the upper limit. Now let me place parenthesis here, because it's upper limit minus lower limit. Now we will do the simplification later, followed by negative. Now you need to place the lower limit here. So this is nothing but shin, in place of u you're going to place negative of shin inverse of 2 over root 3 times, in place of u you are going to place shin inverse of 2 over root 3. This is what you're going to place, right? So let's do that. Now for cos u, this is actually negative shin inverse of 2 over root 3. It doesn't matter with cos u. So cos u will produce the same result that it had produced for this, right? Cos u is going to be root of 1 positive shin squared u, and we write shin u squared u as shin u times shin u, even though we have a negative shin inverse of 2 over root 3. It's not going to impact. So we will still have root of 7 over 3. So that's exactly what I'm going to place here. So this is going to be root of 7 over 3, I close the parenthesis, I give the flower parenthesis. So these things are all done just to bring clarity to the working. Okay, now this is equal to, let 3 over 8 be placed there. Now I've not touched anything, I'm just retaining it because I need to explain something for Shin inverse of 2 over root 3. So let me place that 2 times Shin inverse of 2 over root 3. Now this is going to give me Shin and Shin inverse, they get neutralized, followed by I am 2 over root 3 times, I'm writing it as root of 7 divided by root of 3, negative, negative, positive, Shin and Shin inverse, they get neutralized, giving me 2 times or 2 over root of 3 multiplied with root of 7 divided by root of 3. This is what I have got. It looks lovely. Now we need to know what is Shin inverse of 2 over root 3, right? So there is a small explanation I need to give you. So I'm just looking if I could simplify this quantity, these two quantities. Is it okay if I can just simplify this and move on? So let me just use this part of the page. So this is going to be 2 times the root of 7. Root of 3 into root of 3 gives me 3. Positive 2 times root of 7 divided by 3. If I were to take LCM as 3, this is going to give me 2 times root 7. Positive 2 times root 7. So you add them both. It's going to be 2 times of 2 times root 7, which is going to be 4, right? 4 times root 7. So I can very well utilize that 4 times root 7. So let me rewrite this. So ultimately you got 3 over 8, 2 times Shin inverse of 2 over root 3, positive 2 times 2 is going to be 4 times root of 7 divided by 3. Right? This is what we have got. So we got to be having this in one corner. And then I will provide you the explanation what exactly is this Shin inverse of 2 over root 3, and then we can ultimately simplify. So I need to go to a new page. Let me do that. Now if you remember, I just mentioned to you that I need to obtain the expression for Shin inverse. Now there is a connectivity between natural log and the hyperbolic functions. Right, inverse hyperbolic functions, to be more clear, inverse hyperbolic functions. Now what is the connectivity? Say for example you got y is equal to Shin inverse of x, right? Now I move this Shin inverse to the other side, I get Shin y is equal to x, but I can always write Shin y as e raised to the power of y negative e raised to the power of negative y divided by 2, right? This is the equivalent in terms of exponential functions, right? So that's exactly what I'm utilizing here. Now cross multiply, if you cross multiply you get 2 times x is equal to e power y negative e power negative y. I can rewrite e power negative y as 1 over e power y is equal to 2 times x. So you cross multiply. If you cross multiply you get 2 times x into e power y is equal to e power y into e power y. That's going to be e power y raised to the power of 2 negative 1. You can rewrite this further as e power y raised to the power of 2 negative 2 times x e raised to the power of y followed by negative 1 is equal to 0. Now what I wish to do is I would like to take, let e power y be equal to some t. So this is going to be t squared negative 2 times x t negative 1 is equal to 0. This is a quadratic in t. So if I were to use the quadratic formula, this is going to be negative 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 b, right? The quadratic formula is negative b plus or minus root of b squared negative 4ac divided by 2a, which is given for x. So I am utilizing it for t. So this is going to give me 2x plus or minus root of b squared, that's going to be 4 times x squared positive 4 divided by 2 times of 1. Now this is equal to 2 times x plus or minus. Now 4 can be taken out, right? If 4 comes out it becomes 2. This is nothing but x squared positive 1 divided by 2. So this 2, this 2, this 2 can be cancelled, giving me x positive root of, I'm going to consider a positive value alone. So this is going to be x positive x squared positive 1. This is equal to t. But what is t? T is nothing but e power y. So if you were to take ln both sides, what happens when you take ln both sides? You get ln e raised to the power of y is equal to ln of x positive root of x squared positive 1. And since it's a natural log, e and ln, they get neutralized, giving me y is equal to ln of x positive root of x squared positive 1. But what is y? Y is nothing but shin inverse of x, right? So this means shin inverse of x is equal to ln of x positive root of x squared positive 1. As I mentioned to you, we will have to obtain the value for, this is what we got, right? Let me write that down. We know that from integrating the quantities, 3 over 8 times 2 times shin inverse of 2 over root 3 positive 4 times root of 7 divided by 3. This is what we have got. So if shin inverse is this, therefore shin inverse of 2 over root 3, this is equal to, in place of x I substitute 2 over root 3. So this is going to be ln of 2 over root 3, right, positive square root of 2 over root 3 is going to be 4 positive 3 positive 1, and this can be written as ln of 2 over root 3 positive, this is going to be root of 7 divided by root 3, now which can be rewritten as ln of 2 positive root of 7 divided by root of 3. This is what we have got, root of 7 divided by root of 3. Now we are actually looking for 2 times shin inverse of 2 over root 3. So therefore 2 times shin inverse of 2 over root 3 is going to be 2 times of ln of 2 positive root of 7 divided by root of 3. I'm not going to do anything with the 2 here. Of course, if you want, you can raise it as an index, since we know that if you have a times ln b, you can rewrite this as ln of b raised to the power of a, right? But I prefer to have the 2 over here. So we have got this one, right? 3 over 8 parenthesis 2 times shin inverse of 2 over root 3 positive 4 times root of 7 over 3. So let me substitute this value in place of 2 times shin inverse of 2 over root 3. So this is equal to 3 over 8, 2 times shin inverse of 2 over root 3 is 2 times ln of 2 positive root of 7 divided by root 3 positive 4 times root 7 divided by 3. But as I mentioned to you, this whole thing has to be pre-multiplied with 1 over root 2. I have already mentioned to you that. So this is going to be 1 over root 2 pre-multiplied with 3 over 8 going inside. You get 3 over 8 times 2 times ln of 2 positive root 7 divided by root of 3 positive 3 over 8 coming inside is going to be 4 times 3 over 8 times root of 7 divided by 3. Now 3 gets cancelled, 4 divides 8 2 times, so this is root of 7 over 2, and over here 2 divides 8 4 times. So if I were to bring this 1 over root 2 inside, this is going to be 3 over 4 times root of 2 times ln of 2 positive root of 7 divided by root 3 positive root of 7 divided by 2. And this 1 over root 2 comes inside, so this is going to be root of 7 over 2 times root 2. So this will be the solution. In fact, if you want, you can rewrite the solution in this fashion: root of 7 over 2 times root 2 positive 3 over 4 times root 2 times ln of 2 positive root 7 divided by root of 3. So that's a good place for us to stop.